This is Mr. Beck Does Your Homework, AP Physics, Homework 7.3, questions 9 and 10. A liquid of density 0.99 grams per cubic centimeter, watch out for that, flows through two horizontal sections of tubing joined end to end. In the first section, the cross-sectional area is 11 square centimeters, and the flow speed is 332 centimeters per second. And the pressure is 2.1 times 10 to the fifth pascals. In the second section, the cross-sectional area is 3.1 centimeters squared. Calculate the smaller section's flow speed, answer in units of meters per second. Then calculate the smaller section's pressure. So I have one area constricting into another area. I know that my area times my velocity here is going to equal my area times my velocity here, so that the amount of fluid flowing through both sections of pipe is going to be the same. So now I know my density is 0.99 grams per centimeter cubed. So if I have a density is 0.99 grams per centimeter cubed, well, how do I get that into kilograms per meter cubed? Well, I know there are 1,000 grams in 1 kilogram. And I also know that there are 100 centimeters in 1 meter. But I've got to get rid of centimeters cubed, so what I can do is cube this, and this will give me my density. The cross-sectional area is 11 centimeters squared. Well, how do I turn that into a meters squared? Because I want to get this right. Actually, it's gonna work out where it doesn't matter. But if I wanted to, I could take my 11 centimeters squared to turn it into meters squared. Well, I've got 100 centimeters in 1 meter, but I've got to square that whole thing to get rid of centimeters squared and get to meters squared. The same thing with the other, with the other one is 3.1 centimeters squared. I can do the same thing with that one and get myself an area. So I know an area 1 is going to be this. Area 2 is going to be 3.1, done this same way. And I've got 332 centimeters per second, so I know that 332 centimeters per second times 100 centimeters is 1 meter will give me 3.32 meters per second. So now I've got an area velocity, and I can get an area velocity, and that will give me the velocity in the small side. So here's one area, goes here. Here's a speed, goes here. My other area is going to be the 3.1 plugged in here. That'll give me my other area and solve for my other velocity. Now I want the smaller section's pressure. I'm given the pressure in the one side is 2.1 times 10 to the fifth, and I'm looking for the second side. So now I can use Bernoulli's equation that says P1 plus 1/2 rho V1 squared equals P2 plus 1/2 rho V2 squared. I know my initial pressure, they give it to me here. My density, they give me in here, and I've just calculated, so that's where I use the density. I don't need the density for part 1. My initial velocity, they give me, is in centimeters per second, but I plugged it in meters per second. Pressure 2 is what I'm looking for. 1/2 density, again there is the density. And my V2, that's what I solved for in my first part. So now you know everything. Don't forget to square those. When you get that, you will get a pressure in pascals for the second side. And that pressure, it says answer in units of pascals, so that's what you're looking for.